Assalamu alaikum. Today we have to do the how to obtain image in the plane mirror. So we have to be discussed that about the geometry, how to locate the image behind the plane mirror. So one of the question we solve in that question, we do all the points discussed that which are used to obtain the image location of the image. Figure man looking at his reflection in a rectangular plane mirror. The vertical side of the mirror has a length h. On figure, draw a ray of light from point X is reflected by the mirror to the man's eye. On figure, mark the angle of incidence at your ray diagram. The first point we know that in order to obtain the image behind the mirror, to locate the image behind the mirror, first point is that the image is formed behind the mirror because it is a virtual image. Light rays appears to come from behind the mirror. So actual light rays are not coming. So that is why it is the virtual image. So image is formed behind the mirror and image is formed exactly opposite to the object and its distance from the image is distance from the mirror uh, is equal to the object distance from the mirror. So the first point is that image is located behind the mirror. Then second point is that image is opposite to the object. And the third point is that image distance from the mirror is equal to object distance from the mirror. The fourth point is that the line joining image and object is perpendicular to the surface of the mirror. So mirror to the x point. So the first case, if we measure, so this length is approximately, I use my ruler. So with the ruler, this length is approximately 3 centimeters. So I draw a line that is 3 centimeters. And this is the position at 3 centimeters of x. So in your paper, there is a difference in measurements because according to the paper size or diagram size. Now this is the image behind the mirror. We locate the image. So there are 4 points. Please remember. The first point, image is always from behind the mirror, opposite to the object. Image distance from the mirror is equal to object distance from the mirror, and the line joining object and image is always perpendicular to the surface of the mirror. Now this now the next step is that we draw the reflected rays because the reflected rays, the light rays appears to come from the image. Light rays appears to come from the image. No real light rays coming from behind the mirror. It is a virtual image, so light rays appears to come from the image. So first we draw the reflected rays. So this is the over reflected ray that is the appears to come from the image. Then we draw the incident ray. This is my incident ray. I draw with the green line. So this is the incident ray. I draw the incident ray, which is meet the reflected ray at middle. Now this is the point of incidence. The point of incidence. This is the point of incidence, and I draw a normal. In order to draw the normal, you draw the normal here, and after drawing this, I label this angle I. So this is we locate the image of this foot that the person is able to see. So the first part of this question, figure 5.1, draw a ray of light from the point X that is reflected by mirror to the man's eye. On figure 5.1, mark the angle of incidence, your mirror ray at the mirror. We mark it. How we define the angle of incidence? It is the angle between incident ray and the normal. Always remember that it is always with the normal. On figure 5.1, draw the ray light from the top of the man's head that is reflected by the mirror to his eye. Now the person is able to see his top of the head. Use your rays to determine the smallest value of h that allows the man to see all the image in the mirror from the top of head to his toe. On the diagram, 1 centimeter represents 0.5. Now we required the height of the mirror that is used to obtain full image of the person. So first of all, we persons able to see the head. This is also the approximately 2.93 centimeter. So we draw the same that image is from opposite side of the mirror, behind the mirror, opposite side of the object. Object distance from the mirror is approximately image distance from the mirror. There it is approximately 2.8 centimeter. So we also draw, locate. So this is the image location of the top of the head. This is the image location of head. The image of head, image of top of head. Now the second step is that reflected rays from coming from appears to come from image. So we draw the reflected rays that is enter into his eye. This is the reflected ray. And then we draw the incident ray from the top of the head, which meets the mirror at which meets the reflected ray at mirror. Now the length of the mirror required. The length of the mirror required is this is the region. This is the region from here to here. This is the length of the mirror, these 2 points, this point, from this point to this point. So this is the length of the mirror. This is the height of the mirror, which is required to obtain full image. This is the height of the mirror. This height of mirror. To require the full length of the image. So it is approximately 2 centimeter. I measure it with my ruler. So 2 centimeter to 2 centimeter is equal to 1 centimeter is equal to 0.5 meter. So 2 centimeter equal to, so that will become 1.0 1.0 meter. So in this way, we are able to locate the image behind the mirror. In all the question, this type of question in which we locate the image, that we follow the following steps. Now, one of the key information in the mostly asked in the MCQs that they given you the height of the object and ask that how much is the length of the mirror required to obtain the full image of the object. So the simple formula we have to use in the MCQs, length of mirror, length of mirror to obtain full image is equal to half the length of an object. Thank you.